Welcome everyone to the What Happens When channel, where everyday questions are answered. Before we get into it, why don't you hit the subscribe, like, and smash the notification bell? Okay, let's do this. Our sun, the brilliant star at the center of our solar system, has faithfully illuminated Earth for 4.6 billion years. Yet, like all stars, it won't burn forever. Today, we're exploring a chilling scenario that sounds like science fiction but is rooted in hard scientific fact. What would happen if our sun suddenly ceased to exist? The immediate effects would be both dramatic and devastating. Within just 8 minutes, at the time it takes light to travel from the sun to Earth, our planet would be plunged into an eternal night. This wouldn't be like any darkness we've experienced before. Without the sun's radiant energy reaching Earth, our planet would begin an inexorable descent into a cosmic winter beyond anything in human history. Within hours, the temperature would begin to plummet at an alarming rate. Our atmosphere, which typically maintains Earth's comfortable average temperature of 15 degrees, would quickly become ineffective without solar radiation. Within the first week, global temperatures would drop to an average of 18 degrees. But this would be just the beginning. As weeks turned into months, the mercury would continue its dramatic fall, eventually reaching a devastating 73 degrees, transforming our planet into a frozen wasteland. The collapse of photosynthesis would trigger a catastrophic chain reaction throughout Earth's ecosystems. Plants, which form the foundation of most food chains, would begin dying within days. Without sunlight, these essential organisms cannot perform the crucial process that converts light energy into chemical energy, producing the oxygen we breathe and the food that sustains virtually all life on Earth. This would set in motion a devastating cascade through the food web, affecting everything from the smallest insects to the largest mammals. The oceans, which currently serve as Earth's great temperature regulators, would begin to freeze from the surface downward. The formation of sea ice would start in polar regions and gradually extend toward the equator. However, the complete freezing of Earth's oceans would take several thousand years due to their immense volume and the insulating properties of ice. In this new world, the deep-sea hydrothermal vents would become rare sanctuaries of life, powered by Earth's internal heat rather than solar energy. Perhaps one of the most overlooked consequences would be the loss of the solar wind's protective influence. The sun's continuous stream of charged particles helps shield our planet from harmful cosmic rays. Without this protection, Earth would be bombarded by increased levels of radiation from deep space. Our planet's magnetic field would also weaken over time without the interaction with the solar wind, further reducing our natural defenses against cosmic radiation. For any hope of human survival, we would need to rapidly develop and deploy complex underground habitats. These shelters would need to be entirely self-sufficient, capable of generating their own power, producing food, recycling air and water, and maintaining livable temperatures. This presents an unprecedented engineering challenge that would push human ingenuity to its absolute limits. The development of these facilities would force us to confront difficult choices between personal freedom and collective security. The technology required for long-term survival would need to advance at an unprecedented pace. We would need to perfect nuclear fusion or develop other sustainable energy sources to replace solar power. Agricultural systems would need to function without natural light, requiring significant innovations in artificial lighting and hydroponics. Water recycling systems would need to operate with perfect efficiency, as new water sources would become increasingly difficult to access once surface water freezes. Our species would face perhaps its greatest test of adaptability. The human body, evolved for life under the sun's warming rays, would need to adjust to a perpetually dark and cold world. Vitamin 500 deficiency would become a universal concern requiring careful supplementation. Our circadian rhythms, traditionally regulated by the day-night cycle, would need to be artificially maintained to preserve both physical and mental health. The psychological impact of living in a sunless world would be profound. Human beings have evolved with a deep connection to natural light and its rhythms. The complete absence of sunlight would likely lead to increased rates of depression and other mental health challenges, requiring new approaches to maintaining psychological well-being in underground communities. Yet, within this apocalyptic scenario lies a testament to human resilience and ingenuity. The very technologies we would need to develop for survival, from advanced nuclear power systems to closed-loop life support, are the same innovations that could help us explore and colonize other worlds. In facing such an existential crisis, humanity might inadvertently prepare itself for becoming a truly spacefaring civilization. As we contemplate this dark future, we're reminded of our complete dependence on the sun and the delicate balance that makes life on Earth possible. While the death of our sun is billions of years away, understanding these consequences helps us appreciate the remarkable system that sustains us and drives us to develop the technologies that might one day help us survive without it. In the end, the question isn't just whether technology can outpace the cold embrace of space, but how this challenge might transform us as a species. Thanks for watching.